It began quietly, no dramatic flare, no explosive rupture, no visible signal that anything unusual had happened. Just a spike. A silent, sudden, unmistakable spike in gamma radiation that didn't match any known natural source. At precisely 08:42 UTC on the morning of December 15th, the Fermi Gamma Ray Space Telescope recorded an anomaly. Not a background pulse, not a solar echo. This was localized, focused. A signature burst lasting exactly 31 seconds, centered in the inner solar system, and aligned almost unnervingly with the known position of 3I Atlas. Gamma rays are the most energetic form of electromagnetic radiation. In the cosmos, they are not subtle. They are born in extremes: the collapse of stars, the merger of neutron bodies, the thermonuclear chaos of supernovae. And while distant gamma ray bursts are not uncommon, a burst this sharp, this near, without any accompanying solar activity, immediately raised alarms. Because gamma rays don't just appear from nowhere. Within minutes of the Fermi alert, confirmation began arriving from other observatories. The European Integral Satellite flagged the same event. NASA's SWIFT observatory, tuned to monitor transient cosmic phenomena, registered a spectral pulse in the low-energy gamma band. Across the Pacific, ground-based atmospheric Cherenkov detectors showed a coinciding flash pattern in the high stratosphere. The data told a clear story. This wasn't an error. It wasn't a glitch. It was real. But what was missing made it even stranger. There was no solar coronal mass ejection, no flare from active region AR-385 Volnja, no meteor, no known object entering the atmosphere, nothing that could easily account for such a concentrated spike. And yet, in the exact moment of the burst, the trajectory map placed 3I Atlas within 0.3 astronomical units of the beam's origin, a near-direct overlap inside the ecliptic plane and facing the Sun. Gamma bursts from deep space typically arrive scattered and distorted, bent by gravitational wells and filtered through light years of cosmic dust. But this signal came clean, sharp lines, undistorted curves, as if the source were local and isolated, and that's what caught the attention of the orbital mechanics team at NASA's Jet Propulsion Laboratory. Because when they overlaid the burst's angular coordinates with the known vector of 3I Atlas, they found not just proximity, they found alignment. At the moment of emission, the object had entered what's known as a Sun-Earth opposition wedge, a corridor where light, heat, and now, apparently gamma radiation, reflect directly between the object and our planet. This raised a possibility no one wanted to voice too early. Had the gamma burst come from 3I Atlas itself? Gamma radiation is not something interstellar comets are supposed to produce. They sublimate, they fragment, they scatter solar photons into visible light, sometimes infrared. But gamma, that implies something else, something energetic, something structured, or something reacting. And yet, the timing was exact. The object had just rotated slightly. A telemetry curve showed a microchange in angular momentum. A shadow was cast, then gone. For 31 seconds, the radiation surged. Then silence. It didn't behave like a flare. It wasn't turbulent. It wasn't chaotic. It was ordered. As the day progressed, researchers scrambled to verify the source. And while no one publicly confirmed a direct emission, off-record conversations hinted at what many were thinking. If 3I Atlas emitted gamma radiation, it was no longer just reflecting light. It was doing something more. Because in that silent flash, a question was born, one that no data model could easily contain. What is inside this object, and why did it respond? To understand what made the gamma ray burst on December 15th so unsettling, you have to examine the corridor it followed. The invisible, narrow line through space that connected three bodies in perfect angular sequence: the Sun, the Earth, and 3I Atlas. At first glance, the event looked like a coincidence. A rogue spike in energy, a minor anomaly that just happened to occur near the comet's path. But once orbital analysts began reconstructing the spatial dynamics of that moment, the randomness dissolved into something eerily precise. Because 3I Atlas wasn't just near the event, it was situated along the exact axis of the burst's inferred trajectory. That path is known in astrometry as a solar backscatter vector, a geometric alignment where incoming radiation from the Sun can reflect off a solid surface and reach Earth almost undistorted. It's the same principle that makes the moon glow during a full phase. But this wasn't visible light. This was gamma radiation, and the object reflecting it was not a moon. It was an interstellar intruder with a surface no one had yet resolved. At 0842 UTC, when the burst peaked, 3I Atlas was precisely 1.67 astronomical units from Earth. The Sun was behind it by just under 13 degrees, and between them sat nothing. No planets, no solar debris, no interfering plasma fields, just a clean vector. Under those conditions, any reflection would be sharp, unfiltered, direct, which is exactly what was recorded. Gamma rays typically scatter. They lose focus. They break apart into cascades of lower energy particles as they interact with dust or fields. But this burst was different. Its coherence suggested a reflection off something flat, not irregular or dusty, but smooth. A surface that acted less like stone and more like engineered material. And then came the second anomaly. In the hours leading up to the burst, several ground-based observatories reported a slow, steady dimming of 3I Atlas in the visible band. Not enough to suggest a flare or collapse, just a soft, gradual shift in reflectivity. Almost like the object was rotating, slowly pivoting one of its surfaces away from Earth. But at the precise moment of the burst, that dimming stopped. Instead, a sharp increase in albedo occurred. For 29 seconds, the object reflected more sunlight than at any point in the previous 2 days. It was as though it had rotated into perfect view and then, just as quickly, rotated away. This is what raised eyebrows among astrophysicists studying light curve dynamics, because natural objects don't typically present a single reflective face for such a short interval unless they're tumbling or rotating in sync with an external rhythm. But the motion of 3I Atlas wasn't chaotic. There were no spin irregularities, no signs of random torque. The transition into alignment had been smooth, calculated even, and that's what made the gamma burst so difficult to dismiss. It didn't just arrive near the object, it arrived during the only moment in its rotation cycle, when a flat reflective face was angled between the Sun and Earth. If the gamma energy was reflected, it was reflected by intent, or by geometry so perfect that it mimicked intent. Of course, no one officially declared that 3I Atlas had rotated on purpose, but several research groups, including one at the University of Arizona, began running models. They simulated surface rotation under various axial tilts and exposure rates. What they found was striking. Only one orientation of the object, lasting between 30 and 35 seconds, produced the backscatter curve needed to reflect gamma rays toward Earth. That orientation matched the observed light spike, to the second. In a universe where randomness dominates, this wasn't random. This was a corridor of silence, a clean path, a momentary angle that let something we don't understand become visible, and then disappear. And in that narrow line of sight, Earth caught a glimpse of something no telescope had ever seen, the inside face of an interstellar shadow. When energy arrives from space, scientists study its shape. They don't just ask how bright it is, they ask how it rises, how it falls, how it pulses. Energy always tells a story. And on December 15th, at the moment the gamma burst struck, that story was anything but natural. The spike didn't surge the way solar radiation does. It didn't scatter like a cosmic background echo. And it didn't flicker the way transient bursts from collapsing stars behave. Instead, it formed a triangular wave, a ramp up, a brief plateau, and then a clean drop back to baseline. To physicists, this kind of shape is unnatural. It implies control, because energy doesn't usually follow clean slopes unless something is smoothing it. The gamma radiation wasn't chaotic, it was shaped, bounded on both sides by perfect decline curves. Not noise, not randomness, but rhythm. NASA's Fermi team ran the numbers. They cross-referenced timestamps from every instrument that captured the burst. The Integral Observatory in Europe, the SWIFT, satellite in Earth's shadow, and a pair of high-altitude balloon detectors above South America. The results showed the same waveform, same duration, same profile. More than that, the amplitude was consistent across angles, suggesting a narrow beam. Gamma rays from the Sun typically flare wide, expanding like ripples. This one moved like a lance. It had direction. It had edges. And when they overlaid that energy profile on the known trajectory of 3I Atlas, The line matched. The object hadn't been near the event, it had been inside it. Or perhaps, as some now suspect, it was the event. Of course, no one claimed outright that the object emitted the burst. That would require assuming it has an internal energy source, something no comet should ever possess. But then came the second round of data, residual heat signatures from the gamma contact zone. Using thermal images from the GUS 18 satellite, researchers found a patch of high atmosphere air slightly warmer than normal, precisely above the predicted impact arc. That means the radiation had struck not only instruments, but Earth's upper thermosphere, and still the shape of the spike held. No diffusion, no echo, just a clean input followed by silence. This matters because natural gamma sources don't behave this way. When a gamma burst occurs in deep space, it echoes across thousands of light years, bent and warped by gravity wells, dust fields, and magnetic interference. By the time it reaches Earth, it's shredded, a scatter of half-lives and remnants. But this spike didn't degrade. It retained coherence from entry to exit. The only way that happens is if it started close. And 3I Atlas was the only object close enough and stable enough to account for that consistency. Some theorists, including a group from Caltech, began running speculative simulations. What if the object wasn't emitting gamma rays, but reflecting or redirecting them from an unknown mechanism? Not necessarily a weapon, or even a flare, but something akin to an energy surface, like a gamma mirror, a boundary layer tuned to react to incoming flux from the sun or other sources. This hypothesis is radical, but it would explain the shape. A highly ordered material, possibly a surface panel or skin layer, absorbing ambient energy and reflecting it along a narrow corridor. If such a surface existed, it would produce exactly the kind of waveform observed: rising energy, stable emission, then complete cutoff. 31 seconds of coherence, a smooth triangle, and then nothing. No flare, no dust, no visual outburst, just energy, clean, focused, and gone. In science, you can't make declarations without repeatability, but you can observe, you can follow the shape. And on that morning, the energy shape didn't whisper. It drew a line in the sky and then disappeared into the dark, leaving behind a question as sharp as the spike itself. If this wasn't chaos, then who wrote the signature? Before the spike, before the energy flared across the sky, before any detectors lit up, there was silence. A deep, unbroken, measurable silence in the space around 3I Atlas. And that silence matters just as much as the event that followed. In the 24 hours leading up to December 15th, all solar activity appeared normal. No sunspots erupted. No coronal mass ejections were detected. The solar wind streamed steady and predictable. Instruments aboard the Solar Dynamics Observatory reported calm magnetic fields. Helioseismic readings showed no subsurface shifts. The sun was stable. At the same time, 3I Atlas showed no signs of instability either. Its brightness curve remained flat. Its tail remained faint but coherent. There were no new outgassing events. No sudden flares in the visible ultraviolet or infrared bands. Just slow, silent motion through the inner solar system, what one researcher at ESA described as quiet interstellar glide. And then came the temperature profile. Thermal sensors aboard ESA's solar orbiter, which had been trailing the object from a parallel orbital path, recorded something unusual. In the 12 hours before the gamma event, 3I Atlas's surface temperature dropped. Not dramatically, but enough to be noted. About 3 degrees Kelvin against all expectations. It was moving closer to the sun. It should have been warming. Instead, it cooled. For planetary scientists, this was unexpected. Comets heat up near perihelion. Even if they are made of exotic interstellar ices, the trend is consistent. Proximity to the sun equals heat. But 3I Atlas broke the trend. Not only did it cool, but its infrared signature narrowed, almost like its surface was becoming less porous, less diffusive. One theory proposed that the object might have rotated a non-reflective side toward the sun, essentially shielding itself. But that would cause surface heating to increase, not decrease. Another idea was that an internal gas release cooled the surface briefly. But again, no jets, no tail change, no coma turbulence. The object was silent. Measurably, verifiably silent. Then, 20 minutes before the gamma spike, that silence deepened. ground-based radio dishes scanning the region recorded what they called a temporary suppression of ambient scatter. In plain terms, the background static around 3I Atlas faded. Radio waves from space usually bounce around, off dust, plasma, and thin gas. But for a few minutes, that echo pattern diminished. It was like a shadow passed over the air. Still, there was no visible change, no rotation, no structural movement, just motionless drift. This period, this eerie calm, is what some heliophysicists now refer to as the pocket, a phase of negative activity, no output, no emission, no deviation. Why does this matter? Because the universe is rarely that quiet by accident. Objects in space are noisy. Even dead ones, asteroids, rocks, dust, emit thermal radiation. They scatter signals, they interact with their environment constantly. But 3I Atlas for a brief period didn't. It acted more like a sealed vessel, a blackout surface, something that had either gone dormant or was preparing. And when the gamma burst came, it came at the apex of that silence. The lead researcher at the Canadian Space Weather Lab described the data bluntly. It's like watching someone inhale before a scream. The energy didn't build gradually. There was no pre-flare, no warming crescendo, just vacuum, then signal. For those analysing the moment in hindsight, the silence wasn't absence. It was prelude, a measured mechanical pause before release, like a switch being flipped, or a system powering up. And now the silence is being studied as its own anomaly, because nothing in our models, not cometary, not solar, not interstellar, accounts for this kind of strategic stillness. What was 3I Atlas doing during that pause? Cooling itself? Masking itself? Or readying something we weren't supposed to see? When data sets from different observatories were layered on top of each other, something strange emerged. The gamma burst wasn't just unusual in shape, power, or duration, it was geometrically perfect. A clean, exact alignment between three bodies, the Sun, Earth, and 3I Atlas. This alignment wasn't gradual. It wasn't the result of orbital drift or seasonal shift. It occurred within a narrow window of seconds, at an angular precision of less than 0.1 degrees, and it was only detectable when gamma rays passed directly through the object's calculated solar vector, the same corridor of space the comet had entered only moments earlier. From Earth's perspective, 3I Atlas had moved into what astronomers call an opposition corridor, where incoming light or energy from the Sun reflects straight back toward the observer. This corridor is typically discussed in visible light studies, for moon phases, for planetary opposition events, for measuring reflectivity. But in this case, something far more exotic had aligned. Not light, but high-energy gamma particles. According to orbital simulations run by teams at both JPL and the European Space Agency, 3I Atlas reached gamma opposition, the point where its surface was directly between the Sun and Earth at a precise gamma-susceptible frequency, at exactly 8:42:18 UTC. The burst was recorded at 08:42:19, that's 1 second later, and in orbital mechanics a 1 second offset isn't coincidence, it's alignment. To understand why that matters, consider this. Gamma radiation is directional. It doesn't scatter like visible light unless it hits matter. For it to travel from the Sun, reflect off a small surface like the rotating edge of an interstellar object and reach Earth in one clean beam, every angle has to be exact. The surface must face both sources within 1 angular degree. The object must be precisely located within the corridor, and any deviation in trajectory would cause the signal to miss Earth entirely. But that didn't happen. Instead, the burst hit dead center. Multiple detectors spread across different latitudes and orbital planes captured the same waveform from the same origin vector. It was like something aimed. This is where the terminology started to shift in private memos. Analysts began using words like coincident geometry, specular arc, and transient directive exposure. These aren't terms you use for comets. They're terms used in optics, and sometimes in targeting. One astrophysicist from the University of Tokyo summarized the problem like this. You don't get gamma coherence by accident. You get it by design, or by something acting like a design. That doesn't mean 3I Atlas is engineered, but it does mean the surface presented to the Sun, and Earth was unusually efficient at concentrating energy. There's more. The rotational timing of the object was also synchronized. Based on previous light curve studies, 3I Atlas completes a full rotation approximately every 6 hours and 29 minutes. By calculating back from the burst moment, researchers pinpointed that the object had just completed a rotation exactly 4 seconds prior to the spike. That means the surface which reflected the gamma rays had rotated into position at the perfect moment. No drift, no offset, just motion, then alignment, then signal. Natural objects can rotate, they can reflect. But the timing here wasn't just odd, it was orchestrated. What aligned that day wasn't just physical geometry, it was temporal precision, as if the comet, or whatever lies beneath its surface, had waited for the corridor to form. Because when 3I Atlas entered that beam path, it didn't deflect, it reacted, and the precision of that alignment, spatial, angular, and temporal, now haunts every scientist studying the event, not because it was impossible, but because it was perfect. When objects in space move, they leave fingerprints, not in dust or debris, but in light. Every movement shifts the spectrum, ever so slightly, in what scientists call a Doppler shift. It's how we measure the spin of stars, the wobble of planets, and the direction of entire galaxies. A red shift means something is moving away. A blue shift means it's getting closer, and every shift, no matter how small, tells a story. After the gamma ray burst on December 15th, astronomers expected the energy to fade and the data to stabilize, but it didn't. Instead, they found something new hiding inside the returning light. A faint, deliberate drift in 3I Atlas's motion. Not a full course correction, not a rotation, but a Doppler drift. Subtle, clean, and measurable. This drift wasn't chaotic. It didn't ripple through the object's tail or disrupt the coma. It didn't scatter its surface materials or leave behind any traceable disturbance. It was a frequency shift, a tiny change in how the object reflected sunlight back toward Earth. But that change didn't match any known natural model. What makes it strange is the direction. The drift indicated a brief acceleration, not away from the Sun, which is common for comets releasing gas, but laterally. Sideways, across its orbital vector, as if something inside the object shifted its mass just enough to nudge its path. Not a spin, not a flare, a nudge. In technical terms, the velocity change was estimated at less than 0.15 meters per second. Barely a walk. But in the vacuum of space, even the smallest impulse can result in long-term deviation. And more importantly, it was timed. The shift began within 90 seconds of the gamma burst and returned to baseline just 3 minutes later. A clean onset, a brief plateau, and then stillness. Why does that matter? Because natural outgassing doesn't behave this way. When a comet vents gas, it does so unpredictably. Ice cracks, gas escapes. Dust blows out in irregular patterns, pushing the body in wild microspins and chaotic tumbles. But that's not what happened here. There were no signs of venting, no plume trails, no coma brightening. Nothing visually changed. Only the light told the truth. A Doppler drift without visible propulsion, a motion without a jet. This suggested 2 possible causes, and neither was easy to explain. The first theory is mass redistribution, that inside the comet something moved. A slab of material slid, a pocket of compressed gas shifted, an internal cavity collapsed. If 3I Atlas has a hollow interior, this could explain the momentary change in momentum. But again, there were no visual tremors, no tail wobble, no shadow distortion. The second theory is recoil, that the gamma burst wasn't just reflected, it was emitted, and if energy was discharged in one direction, Newton's law demands an equal and opposite reaction. Even photons, though massless, carry momentum. A sustained gamma emission, even for 31 seconds, would create a measurable push in the opposite direction. And that's what the Doppler data suggests. A push. Small, deliberate, one-sided. No comet in recorded history has shown this behavior. Even 1I Oumuamua, the first known interstellar object, never displayed a clean Doppler drift without visible gas or debris. This was new, and that's why analysts at NASA's Deep Space Network began remodeling 3I Atlas's future trajectory that very night. Because this wasn't a drift caused by ice, it was a response, a subtle correction, as if the object had finished something and adjusted itself before continuing, just a few centimeters per second. But in the language of space, that's not noise, That's navigation. In the hours after the gamma burst, most telescopes continued tracking 3I Atlas as usual, measuring light curves, monitoring its coma, watching for jet activity. But a different kind of measurement was already underway, one that didn't focus on the object's surface, but on what might lie just beneath it. The Max Planck Institute for Solar System Research, using a ground-based optical polarimeter array in Namibia, analysed the polarised light returning from 3I Atlas. They weren't looking for brightness, they were looking for behaviour. The way light twists when it bounces off certain surfaces, the way it changes if it travels through translucent layers or ricochets off boundaries hidden inside. What they found was unexpected. Instead of a single, uniform reflection, typical of dusty comets or icy bodies, they recorded a dual-phase reflectivity pattern. In simple terms, part of the light bounced off the surface, the rest didn't. It passed through. This suggested semi-transparency, but not in the way of glass or water. The spectral signature indicated something dense, something structured, something layered, as if the outer shell of 3I Atlas wasn't solid, but partially hollowed, or filled with material that selectively allowed light to enter, scatter internally and reflect out again. In astrophysics, this is rare. Most space rocks are opaque. Their surfaces are dusty, fragmented, inconsistent. Even icy comets reflect light in chaotic ways due to uneven sublimation. But this object behaved more like a light trap, absorbing certain frequencies, bouncing others back cleanly, and the most reflective band wasn't in the visible range. It was in the near-gamma region, an ultra-short frequency band right below the spectrum that triggered the December 15th anomaly. That discovery sent a ripple through the small community of scientists studying optical polarization at interstellar distances. One internal report from the German Aerospace Center put it plainly: the object is behaving like a shell, a partially reflective, internally reactive shell. That's not consistent with known cometary surfaces. So what could do that? One answer is geometry. Thin layers of ice or carbonaceous material stacked in irregular sheets might cause partial transparency. But those materials don't typically reflect gamma or near-gamma energy. They scatter it, bleed it into heat. The only known materials that reflect high-energy photons with coherence are metallic composites, structured alloys, engineered materials, and then came the timing. The dual-phase reflectivity was only observed after the gamma burst. Earlier polarimetry readings showed simple scatter, light bouncing in random patterns. But after the burst, the readings changed. A secondary reflective band appeared nested inside the original signature, and it lasted exactly 2 hours before fading. That implies one of two things. Either something opened during the gamma burst, exposing an inner layer that reflects differently, or something activated. A field, a texture, a system, and that's where the theories start to fracture. Some researchers believe the surface of 3I Atlas may contain phase-sensitive materials, compounds that change optical properties under heat or radiation. Others argue it's just a coincidence, a random reflection off an unusually flat facet of a rocky interior. But one thing no one can explain: the precision of the light curve after the event. The object didn't brighten randomly, it reflected more light in specific bands, with symmetrical peaks, with rhythm. For a natural comet to do that, it would need a level of structural consistency no comet has ever shown. So what was the internal layer reflecting? Was it part of the object, or was it something within? Because the data didn't show a flash from outside, it showed light escaping from the inside, momentarily perfectly and then sealed again. Whatever reflected that gamma energy didn't do so by accident. It did it like a mirror with memory. While major observatories analysed the gamma burst and Doppler drift with high-precision instruments, a smaller, quieter discovery came from an unexpected corner of the world. A group of amateur astronomers in Nagano, Japan, operating long-exposure CCD arrays from their mountaintop observatory, caught something no one else had seen. It wasn't a jet, it wasn't a tail event, it was a flash. A single, faint flash, lasting just under half a second, recorded at 084220 UTC, exactly 1 second after the gamma spike was first detected. It didn't appear in the visible band but in the near-infrared, and most importantly it wasn't coming from space at large. It originated from within a tightly defined pixel zone. The coordinates matched the estimated position of 3i Atlas with uncanny precision. When the team submitted the finding to the International Astronomical Union's Transient Event Network, they initially flagged it as a potential cosmic ray hit. These are common in amateur CCD data, rogue high-energy particles triggering light in the sensors, often dismissed as noise. But this wasn't noise. Cross-verification soon came in from South Korea, where a university observatory had captured a similar flash at the same time in the same angular position using a completely different system and sensor array. And just like in Japan, it had lasted less than half a second. Bright, contained, and gone. 2 independent flashes. Same timestamp. Same location. Same duration. And that's when researchers started paying attention. The flash was small. So small that it didn't trigger alarms in the large-scale observatories that focus on high-energy bursts. It wasn't intense enough to register as a flare, but it was concentrated, which is what made it strange. Normally, light from comets diffuses. Dust reflects light in soft gradients. Even ice-rich jets spread energy across broad areas. But this flash was tight, surgical, like a signal, not a flare. Further analysis showed the light had an unusually narrow emission angle. It didn't scatter, it pulsed. In optics, this type of beam-like coherence usually comes from controlled reflections or energetic discharge, like the brief flicker from an igniting capacitor or the blink of a laser caught on the edge of a mirror. But there's no known natural mechanism in a comet that can release energy in such a focused way, especially without heating the surrounding coma. And that's the next puzzle. Despite the flash, there was no corresponding temperature spike. Thermal maps from the GUS-18 satellite and the European Solar Orbiter showed no significant heat bloom. The coma stayed stable, no jets, no brightening. The object's energy profile, aside from that one flash, remained eerily quiet. It was like something inside the object had blinked open for a fraction of a second, and then sealed shut. And here's where the geometry becomes chilling. That flash occurred at the leading edge of 3i Atlas, the same edge that had reflected the gamma burst moments earlier, the same surface that polarimetry had flagged as layered and semi-reflective. If this was coincidence, it was an astronomically unlikely one. One theory: the flash was residual discharge. If 3i Atlas is reflective in the near gamma spectrum, the internal buildup of energy could create a momentary overload, venting through a weak point. But that would require the object to behave like a capacitor, storing and discharging energy with intention. Another theory: the flash was a secondary emission, like a Morse code tap in deep space. Not a message in the human sense, but a pattern, a release, a marker. What's certain is this: 2 unrelated amateur observatories separated by thousands of miles captured the same impossible flicker at the same impossible moment. And they caught it where no light should have been. It wasn't bright enough to blind. It wasn't long enough to explain. But it was real. And sometimes, the universe speaks not through explosions, but through a single silent blink. Once the hidden flash was confirmed, attention turned to what it might have revealed. Not through light, but through absence. Spectral analysts reviewing data from the Swift Observatory noticed something peculiar. During the moments before and after the gamma burst and the flash, a consistent absorption line began to fade. Not just shift, fade. It was a carbon line, specifically the C2 line, a marker often used to track the chemical composition of comets. Normally this line is stable across a comet's outer coma, showing carbon-rich dust shedding as the comet travels. In 3i Atlas, that line had been steady for days, even as the object neared Earth. But on the morning of December 15th, something changed. Just after the gamma burst and nearly simultaneous flash, the carbon absorption signature dropped, first by 10%, then by 30%, until less than 40 seconds after the event it was gone entirely. No C2 line, no carbon shadow. Gone. This wasn't just unusual, it was unprecedented. Even in fragmented comets, carbon lines persist as remnants float in the coma. Even dying comets expel traces. But here, a complete absence was recorded, as if the carbon had either stopped emitting, had been absorbed, or had been removed. NASA's Deep Space Spectral Archive flagged the event as anomalous. Analysts initially thought it might be a sensor error, but the carbon drop was mirrored in data from 3 other instruments. the James Webb, the Solar Orbiter, and a long-range Earth-based array in Chile. All had detected a clean silence where there should have been a carbon echo. That silence created what astrophysicists now refer to as the carbon shadow. And in that shadow, new questions began to form. The most immediate theory was shielding. Perhaps 3I Atlas had rotated slightly, and the side facing Earth was now a shielded crust, blocking carbon ejection. But thermal readings and light reflection patterns remained unchanged. No rotational axis shift was detected. Another theory was internal sublimation. If the comet's carbon-rich layer had been explosively vaporized, it could theoretically result in a temporary pause in emissions. But again, there were no spikes, no thermal bloom, no trailing dust, no evidence of loss, only the absence of signal. And that's when a third theory emerged, one more unsettling than the others. A select group of atmospheric physicists proposed that the gamma burst had induced a chemical phase change inside 3I Atlas. Not a simple melting or sublimation, but a shift in molecular state, triggered by energy input beyond known comet behavior. In simpler terms, the carbon didn't vanish. It stopped being detectable. Such phase transitions are incredibly rare in nature and typically require engineered environments. Laboratories on Earth can replicate these changes, but only under tightly controlled conditions involving pressure, magnetism, or exotic catalysts. To witness such a shift in open space, without fragmentation, without heat, that should be impossible. Yet the carbon line was still gone. And perhaps more disturbing, secondary molecules usually linked with carbon, like cyanide, hydrocarbons, and sulfides, also began to dim, not all at once, but in a cascading pattern. A molecular reorganization was suspected. It's as if the outer structure of 3I Atlas, once carbon-rich and chemically active, had begun sealing itself, not randomly, but precisely. A sort of chemical cloak. Scientists from the ESA suggested that the object might be deploying reflective or absorptive materials across its surface, not unlike chameleon shielding in military tech, to adapt to the gamma energy it had absorbed. That would mean 3I Atlas isn't just reactive, it's adaptive. The carbon shadow, then, isn't merely the absence of signal. It could be the first visible sign that something inside this object is changing, not decaying, not breaking, but evolving. And that silence, cold and chemical, might not be a death, but a decision. The moment the carbon shadow was confirmed, something else began to unravel, this time not hidden in the spectrograph, but plainly visible in the optical range. Observatories around the globe, from Chile's Cerro Tololo to NASA's SOFIA platform, noticed a sudden shift in brightness. At first it was subtle, a small drop in visible magnitude, barely outside the margin of error, but then it accelerated. Within 3 minutes after the gamma-ray event near 3I Atlas, its optical brightness had dropped by nearly 30%. Within 7 minutes, it halved. By the 9-minute mark, the object was nearly invisible in long-range optical scans. This wasn't just dimming, it was disappearance, and yet radar and infrared tracking continued as normal. 3I Atlas was still there. Its heat signature hadn't faded, its trajectory hadn't changed. The comet, if that's what it still was, remained on course, but to visible light it was vanishing. Telescopes switched filters in real time to confirm this wasn't atmospheric interference or sensor lag, but every platform across multiple latitudes and instruments reported the same result. The brightness dropout was real. At first, scientists attributed it to surface rotation. Perhaps a darker side of the object had rotated into view, a featureless plane or carbon black crust. This would explain the loss in brightness without requiring anything too exotic. But this theory broke down under deeper analysis. The object's rotation, already mapped by earlier studies, couldn't account for such a rapid and total fade. Even known low-albedo comets never dim this fast without fragmentation, and 3I Atlas hadn't fragmented. There was no debris, no tail distortion, no thermal spike. The object was intact. So if it wasn't rotation, and it wasn't atmospheric interference, then what was it? That's when a parallel was drawn, not to comets, but to stealth technology. In modern aerospace design, aircraft can adjust surface geometry and absorbent materials to reduce radar and visual signatures. Adaptive camouflage is rare in space, but not impossible in theory. And suddenly, 3I Atlas seemed to be doing exactly that. Theories emerged about surface coatings, volatile compounds that, once activated by a gamma burst, could realign molecularly to scatter or absorb visible light. Materials like Vanta black or metacoatings had been developed in labs to do similar things, but never on a natural object, and never across an entire structure this fast. The term brightness dropout became shorthand for what was unfolding, but that phrase didn't capture the full mystery, because brightness fading implies passive loss, a comet cooling, dimming with distance. This wasn't that. This was intentional occlusion, as if the object had received too much attention and decided to shut the lights off. The most disturbing part? Light from the sun was still hitting it. Spectral. Backscatter showed minimal reflection, almost none. Yet infrared proved the surface was still absorbing energy. It just wasn't bouncing it back, like a cloak drawn over a machine. Some scientists resisted the implication, preferring to see this as a non-standard outgassing event. That phrase began circulating in white papers and closed briefings, but even they had to admit, no gas jets were visible, no tail expansion observed, and then something happened that no one expected. For a brief 6-second window, a high-speed imager from an ESA probe caught what looked like a structured shadow moving across the object's surface. Not a cloud, not a crack, but a shape, angular, layered, and momentary, almost like panels folding in. After that, the object dimmed beyond optical detection, and never brightened again. That silence in light, what scientists now call the brightness dropout, wasn't just an observational problem, it was a statement. Something on or within 3i Atlas no longer wanted to be seen. While attention was locked on the visual fade of 3i Atlas, another anomaly unfolded. Not out in deep space, but much closer to home. Instruments aboard multiple Earth-orbiting satellites detected a sudden sharp spike in the planet's upper magnetosphere. The readings didn't match solar flare patterns or standard cosmic radiation surges. Instead, they bore the unmistakable signature of a direct electromagnetic interaction. The spike began less than 4 minutes after the gamma-ray burst was recorded near 3i Atlas. The alignment wasn't perfect, but the timing was too close to ignore. Satellites from the GOES and Themis missions, as well as ESA's cluster array, all reported the same effect, a sharp elevation in local magnetic field distortion between the upper thermosphere and exosphere. This was not a widespread storm. There were no auroral displays, no interference in GPS or radio. Instead, it was concentrated, tightly focused over a region spanning only a few hundred kilometers above the equator, centered roughly on the suborbital position directly beneath 3i Atlas at the time. To visualize it, imagine a single thread of interference, like a thin spike of static being pushed into Earth's electromagnetic shell. Narrow, deep, and isolated. Not a blanket, a needle. The phenomenon lasted approximately 12 seconds. Short, quiet, but precise. And then it disappeared as quickly as it came. Initial assessments considered whether a minor coronal mass ejection from the sun could be responsible. But solar observatories showed no concurrent flare activity. The sun had been quiet for hours prior. There was no wind event, nothing to account for what happened. What made the event more troubling was what it did not do. It did not ripple outward like a wave. It did not fade gradually. It snapped in like a command and snapped out like a pulse. One explanation offered in internal NASA briefings was localized field, resonance, possibly triggered by unknown space plasma interactions. But buried deeper in those reports were red-flagged pages marked for restricted review. These mentioned the word coherence, a term normally reserved for systems, engineered systems, that can synchronize with and exploit ambient energy structures. That's when things took a darker turn. If coherence was the right term, what had just synchronized with Earth's upper field? The implications rattled even the more cautious members of the planetary science community. For coherence to occur across this distance, from 3i Atlas to Earth, there would need to be a shared frequency reference, some measurable bridge, and the only event that fit the timing was the gamma-ray burst. Not a normal burst either, one with an unclassified emission line. Gamma bursts are among the most powerful known events in the universe, but they are also chaotic, noisy, unpredictable, and diffuse. But this one wasn't. Its waveform had structure. And now Earth's magnetic field had responded. Theories began to emerge, some public, most not. Was this a side effect? A freak resonance as energy passed through a previously unknown pathway? Or was this the result of targeted emission? That phrase, targeted emission, showed up in one internal paper from a Canadian aerospace researcher contracted by ESA. He pointed out that the spike had occurred in a band heavily used by satellite communications, and yet not a single signal had been disrupted. Instead, it occupied the gap between key civilian and military channels, as if it had been threaded deliberately, not just energy, intention, and it wasn't over. In the hours that followed, a pattern of micro-distortions began to ripple across high-altitude sensor buoys in the Pacific, each one echoing the magnetospheric spike, not in strength, but in timing, each wave, each pulse, exactly 47 minutes apart, as if Earth had been pinged and was now responding. No one said the word communication publicly, but behind closed doors it hung in the air like static. It wasn't just a one-time pulse. That much became evident before dawn had even broken across the Pacific. Just as systems were beginning to settle after the magnetospheric spike, a second wave arrived, not from the Earth this time, but once again from deep space, and it followed the exact same directional vector as the first gamma-ray burst, straight from the vicinity of 3I Atlas. But this time, it wasn't a gamma spike, not technically. What Earth's instruments picked up was subtler, not blinding, not overwhelming. It was a layered frequency emission, narrowband and highly structured, a sort of soft hum in the background static of the universe. But it wasn't noise, it had a symmetry, a mirrored architecture, and above all, it had timing. At exactly 47 minutes and 22 seconds after the initial gamma-ray event, this second emission was detected by 3 orbiting observatories, Fermi, Swift, and China's GCAM-C. Each reported a multi-frequency pulse, one peak in soft X-ray, another in microwave, and a final harmonic in low infrared, all synchronized to a near-perfect temporal alignment. In other words, it was a stacked emission. Not random, not astrophysical debris. Engineers familiar with signal modulation described it as a chirped triad, the kind of thing you'd expect from an advanced communication or detection system, not from a tumbling icy rock. But if it wasn't natural, what was it? Scientists scrambled to interpret the burst. What could cause something like this? Some proposed thermal realignment, that perhaps the object was undergoing a late-stage core adjustment, and the emissions were simply internal energies being vented through different materials in different layers. But that explanation collapsed quickly. The spectral signatures of the emissions didn't match thermal dispersion. They matched precision modulation. The frequencies were evenly spaced, with harmonic fall-off curves that suggested digital imprinting, as though they had been constructed with an internal logic. Worse, they repeated. 5 minutes after the first pulse, the same emission wave appeared again, and then again, and again, each one degraded by less than 0.1%. The stability of the signal pattern ruled out any kind of fragmentation or radiation echo. What Earth was receiving was direct, and it was repeating in a loop, like a beacon, or worse, a handshake request. The language of it wasn't known. No one could decipher content or intention, and official bodies were careful to avoid saying too much. But those monitoring deep space communication bands began referring to it by a new name, Echo 47. Unofficially, it had become the subject of quiet panic. To those who believed in extraterrestrial engineering, Echo 47 was confirmation of an intelligence behind 3I Atlas. But to those who feared the implications, the signal was something else entirely, a test. What disturbed analysts most wasn't the presence of the emission. It was the behavior of Earth's own field in response. Each time the wave arrived, Earth's upper ionosphere reacted, not violently but predictably, with a faint, synchronized oscillation, barely detectable by ground radar but unmistakable in high-frequency atmospheric sensors. It was as if the wave wasn't just hitting Earth, it was interacting with it. Mapping software showed an oscillation grid forming across the planet's surface, with faint energy nodal points lining up along several geomagnetic fault lines, from the Pacific Ring of Fire to the South Atlantic anomaly. This wasn't heat, it wasn't visible light, it wasn't traditional electromagnetic interference, it was rhythm, pacing, as if something out there, near 3i Atlas, was not only transmitting, but waiting. This second wave changed the entire tone of the investigation. No longer was the gamma ray burst seen as an isolated burst of energy. Now it looked like a trigger, the first action in a sequence that had only just begun. And for those watching closely, it raised the most unnerving question yet. Was Earth being scanned? Even as the second wave of emissions continued looping, eyes turned toward the rear of 3i Atlas, to the structure everyone assumed was a tail. But in the infrared band, something didn't fit the traditional profile of a cometary dust stream. On December 15th, just after the repeat signals of Echo 47 began, the James Webb Space Telescope was tasked with reorienting one of its deep field sensors. Its target, the thermal footprint of 3i Atlas's tail. What it captured didn't resemble any known cometary body. In fact, it didn't behave like a tail at all. Instead of a gradual dispersal of heat or a fading radiation curve as dust moved away from the object, Webb detected 3 distinct thermal nodes along the tail, each with fluctuating intensity, separated by evenly spaced intervals. The fluctuation pattern, identical to the timing of the Echo 47 pulses. Scientists expected to find chaotic heat signatures typical of a fragmenting object. Instead, what they saw was a structured thermal waveform, like 3 beating hearts pulsing in rhythm behind the nucleus. And then came the inversion. One of Webb's passes during a thermal lull in the tail showed that one node, the farthest, went cold, while the center node spiked. It was as if energy wasn't dispersing outward but being drawn back inward, against the direction of momentum. This was physically impossible under classical comet dynamics. What could cause such a reversal? Plasma simulations failed to explain it. A magnetic slingshot mechanism was proposed, but the distances were too compact. Some speculated the thermal readings weren't emissions at all. They were absorptions, indicating active intake of ambient radiation. That alone was unprecedented. And then, something even stranger occurred. As Earth's orbit shifted slightly and the angle of view changed, astronomers noticed the nodes weren't static in space. They were rotating. Each infrared pulse twisted around the central axis of the tail, forming a slow but consistent helical spiral. It wasn't just heating, it was coiling, as if forming an artificial sheath around the object's wake. Suddenly the tail didn't seem passive anymore. It felt constructed, and it didn't end there. Spectral analysis of the tail region revealed micro-reflective particles that responded to starlight differently than standard cometary dust. These particles weren't diffusing light randomly. They were polarized, aligned in a consistent direction, as though held in place by an external force. One theory emerged, whispered first in private observatory chat rooms and later in encrypted scientific channels: tail shielding. If true, it would mean that 3i Atlas was actively managing the shape, temperature and electromagnetic properties of its tail, not to disperse debris, but to mask emissions or redirect detection attempts. The implications were massive. What looked like a harmless stream of outgassed ice and dust might instead be an engineered field, a thermal camouflage array, hiding whatever lay beneath from infrared surveillance. And it explained why Earth only caught brief glimpses. The heat signatures weren't failing. They were fluctuating on purpose. It all pointed to one unsettling conclusion. 3i Atlas wasn't just arriving, it was concealing its state on approach. Infrared telescopes across the globe updated their scanning protocols. Filter algorithms were rewritten to track asymmetric thermal echoes and secondary wave refractions. But by the time adjustments were in place, the fluctuations had slowed. The 3 thermal nodes dimmed again, not to silence but to a stable, low-output rhythm. Like a system returning to standby mode. And just like that, the helical twist began to unravel. The spiral faded, and the tail softened into the appearance of randomness again. Except, it wasn't random. It had ended its display, and Earth had been allowed to see it. While most attention was focused on the tail's strange behaviour, one anomaly from December 15th went largely unnoticed, until it refused to correct itself. It was the absence of a core reflection. Normally, even the darkest celestial objects, whether asteroids, comets, or rocky moons, reflect at least a faint band of starlight or solar glint when viewed from an angle. Especially when backlit by the sun, a nucleus reveals at least a partial contour, But this time, as Earth's telescopes tracked 3I Atlas's rotation, one sector remained entirely black. Not dim, not low albedo, black. It wasn't an observational error. Instruments across 5 nations confirmed the same result. Light entering the region simply didn't come back. When a comet's core absorbs that much light, the assumption is usually dust occlusion or fragmentation. But this wasn't dust. There were no density plumes in that region. And it wasn't fragmented. The structure remained whole, rotating smoothly. It was as if a part of the nucleus had stopped reflecting entirely, as if something on its surface was actively absorbing all light and not re-emitting it across any band. Not optical, not thermal, not even radar scatter. That's when someone made the chilling comparison. It looked exactly like stealth coating. This concept isn't new. Earth's military has developed radar-absorbent materials for decades, and newer spacecraft designs incorporate metamaterials that minimize detection. But never has such technology been seen on an interstellar object. The shape of the blacked-out region wasn't random either. High-res telemetry showed that it formed a geometric crescent, almost like a protective cover, or docking interface, and it was moving. Over the next 2 hours, this non-reflective sector rotated away from view, as if it were part of a larger structure anchored to the core's axis, not natural terrain, but mechanical in nature. Once out of direct observation, the region emitted a strange secondary anomaly, a brief temperature dip in the surrounding shell, like something had opened or closed. This was the moment many in the scientific community dropped the term comet from their internal reports. What Earth was observing no longer behaved like an icy interstellar traveller, it behaved like a ship. No one would say it publicly. But behind closed doors, agencies began assigning 3I Atlas a new internal classification, non-passive foreign body. The lack of core reflection became more than a curiosity. It was now a strategic blind spot. Telescopes reoriented, radar scans were intensified, and AI models tasked with edge detection began highlighting the silhouette of the region with high probability of engineered structure. Still, no detail emerged. It remained, frustratingly and persistently, invisible. Even the sun offered no assistance. When 3I Atlas briefly passed into partial solar backlight, the crescent core remained fully dark, as though even direct solar radiation had been trapped. That's when speculation gave way to worry. Because for the first time, the object showed an ability Earth wasn't sure how to counter. Intentional invisibility. A feature, not a flaw. And just as the world scrambled for answers, that sector reappeared, faintly, barely, but with a single spectral spike in deep ultraviolet, as if it was signalling that it could be seen, only when it chose to be. The term afterglow typically refers to the residual radiation following a gamma-ray burst, a fading echo of unimaginable energy. But what happened on the evening of December 15th wasn't a fade. It was a re-emergence, and it happened much closer to Earth than scientists were prepared for. Roughly 6 hours after the Echo 47 pulse and the Tails infrared anomaly, Earth's polar orbiting satellites began detecting low-level gamma spikes. Not from deep space, but within the magnetosphere itself. This immediately caused alarm. The magnetosphere is Earth's protective bubble, a magnetic field extending thousands of kilometers into space, deflecting solar wind and shielding the planet from cosmic radiation. Gamma rays are not supposed to accumulate there, and yet sensor networks, particularly NOAA's GOES 16 and ESA's Sentinel satellite constellations, recorded short-duration, high-frequency bursts echoing along the inner Van Allen belt. The readings didn't match solar flares, nor were they consistent with lightning, nuclear signatures, or terrestrial gamma-ray flashes as TGFs. Instead, they matched the fingerprint of the burst that came from the direction of 3I Atlas just hours earlier, a burst Earth's telescopes had barely caught before it dimmed. That same signature now echoed in Earth's sky. At first, analysts speculated that this was simply delayed reflection, gamma rays bouncing off interplanetary dust or the lunar surface. But timing models ruled that out. The delays didn't align with any known reflective body or orbital path. That's when a new and far more disturbing hypothesis emerged. The burst had passed through Earth's field, and the magnetosphere was now resonating with the imprint. Picture a bell struck by a sound so pure it rings with a tone long after the impact. That's what the magnetosphere was doing, oscillating faintly but precisely, with the frequency of a cosmic event. Except Earth's magnetic field is not a passive bell. It's a dynamic, reactive force, which meant it wasn't just ringing, it was modulating. Soon, regions over the South Atlantic anomaly, the weakest point in Earth's magnetic shield, began showing irregular spikes in radiation. Aircraft rerouted, ISS crew were notified. Low Earth orbit systems started receiving interference, and high-energy particles from the gamma echo caused sensor blinding in multiple satellites, forcing emergency safe modes. By now, mission control centers across Europe, the United States and Japan were on high alert. If this wasn't just a cosmic reflection, if this was some kind of backscatter echo from the burst that passed through Earth, it meant one thing. The energy from 3I Atlas's burst had touched the Earth's magnetic barrier and left a trace, a fingerprint. Worse, some began to wonder if the burst wasn't random at all. What if it was targeted? What if this pulse wasn't a warning shot or a malfunction, but a test of Earth's magnetospheric response? That thought changed everything. Suddenly the afterglow wasn't just radiation, it was a signal, an echo still bouncing in Earth's magnetic shell waiting to be decoded. Earth-based magnetometers tried to record the harmonics, but every time the gamma wave resonated again, it altered slightly, as though adjusting, learning. The shape of the waveform began shifting by fractional degrees. Some analysts claimed it looked like a feedback loop. Others went further. They said it resembled a handshake protocol, one designed to establish resonance between two systems. And then came the pattern. On its sixth cycle, the gamma echo repeated a structure, not just a waveform, but a fractal modulation that showed recursive self-similarity. That's not natural. That's not random. That's engineered rhythm. At 3:14 a.m. UTC, the Van Allen belt flared once more. Just as suddenly the afterglow stopped. No more pulses, no more resonance. Earth's field went quiet, like the signal had achieved its goal and moved on. It was perhaps the most unsettling moment in the entire 3I Atlas observation timeline. After weeks of strange emissions, tail spirals, magnetic pulses and gamma bursts, the object stopped. At precisely 03:19 a.m. UTC on December 16th, every sensor watching 3I Atlas went flat. No infrared signature, no ultraviolet flares, no polarized scatter, no frequency modulation. The object, for all practical purposes, went dark, and not gradually, instantaneously. This wasn't a slow decay or signal attenuation. It was a shut-off, abrupt, deliberate, and chillingly precise. The first assumption was that it had fragmented, that some internal instability had finally torn it apart. But optical imaging still showed its silhouette. The structure was intact. The motion remained consistent. The orientation even held steady along its Earth vector alignment, so it hadn't disintegrated. It had simply stopped emitting. No thermal flux, no charged particle outflow, no Doppler variance, not even background outgassing, which had, up to this point, been one of the few natural traits 3I Atlas displayed. That too was gone. It was as if a machine had been powered down, and this terrified everyone watching. What kind of object, especially one travelling from interstellar space, ceases all emission at once, across every band of detection? Some believed it was hiding, switching into a dormant phase to avoid further scans. Others speculated that it was listening, turning silent in order to receive something from Earth or from elsewhere. But the most disturbing theory came from a small group of orbital physicists. It had transitioned from observational to operational mode. In other words, the show was over. Whatever 3I Atlas came to do, it was now beginning. It no longer needed to emit. It no longer needed to communicate, distract, or perform. It had arrived at the point where action would follow, and that's when the model started changing. Trajectory simulations that once showed minor deflections now began showing a tightening arc, not around the Sun but increasingly in synchronous drift with Earth's orbital path, not intercept, not collision, shadowing. Like a predator stalking from a distance, moving with the same rhythm, the same beat, just far enough to remain out of reach, yet close enough to respond instantly. And that's not even the worst part, because one last measurement slipped through, buried in the early data from the moment it shut off. Just as the object dimmed, a faint electrostatic charge was recorded along its outer field, a residual pulse, like the last flicker of a capacitor discharging. Only one detector caught it, but the frequency it emitted was in the audible range, not for deep space, for ears, as if, in its last moment before silence, it wanted to make one final statement, a whisper unheard by most, but unmistakable to those who caught it. Now it was Earth's turn to listen, because Three-Eye Atlas was no longer trying to be understood. It had entered a different phase, and no one knew what came next. Auroras are among the most breathtaking natural spectacles on Earth. Luminous curtains of green, violet, and red light dancing across the polar skies. For centuries they were seen as mystical omens. Today, we know their cause: charged solar particles colliding with Earth's upper atmosphere, guided by the planet's magnetic field toward the poles. But what occurred on December 16th shattered that model. Because for the first time in decades of observation, Earth experienced a polar aurora with no corresponding solar wind activity, no coronal mass ejection, no flare, no sunspot alignment, nothing from the sun. And yet, the sky lit up. It started around 0412 UTC, just as Three-Eye Atlas had gone completely silent. Ground-based aurora monitors in Norway, Alaska, and southern Greenland began picking up faint light emissions across the upper atmosphere, consistent with high-latitude aurora events. But satellite data from NASA's Solar Dynamics Observatory and the SOHO spacecraft showed no flux from the sun, no disturbances, no spikes. The solar wind was stable, so what was energizing the ionosphere? The lights quickly intensified. Within 30 minutes, the auroral oval expanded across both hemispheres, painting the skies over Iceland, northern Canada, and parts of Siberia with glowing arcs, but with a strange purple-pink hue rarely seen in typical aurora events. Spectral analysis revealed an unusual emission line, not from nitrogen or oxygen, the usual culprits, but from ionized carbon. This made no sense. Carbon auroras? That would require either a completely different source of particles or a radical new interaction. And that's when a new possibility emerged. The energy wasn't coming from the sun, but from within Earth's own magnetosphere. Teams from the European Space Agency and NASA quickly cross-referenced particle injection data. They found a spike. Roughly 45 minutes after Three-Eye Atlas's last recorded emission, Earth's magnetic field recorded a localized inversion, a brief reversal of magnetic polarity near the North Pole, lasting only 2.3 seconds, just long enough to let something through. Not particles from the sun, particles from interplanetary space, possibly even directly from the tail region of Three-Eye Atlas. And now they were interacting with Earth's upper atmosphere. Auroral watchers noticed something even stranger. The patterns of the aurora weren't random. They weren't just waving. They were pulsing in slow rhythmic beats, not unlike Morse code. Every 35 seconds the light would intensify in a specific quadrant, then pause, then flare again in another. This pattern repeated for over 2 hours. Spectrographs captured harmonic resonances, not just in visible light, but in the low-frequency radio bands. To some observers, the sky didn't just glow, it sang. Amateur ham radio operators across the northern hemisphere reported bursts of static synced to the auroral pulses, sometimes layered with faint, almost melodic oscillations. Some claimed to hear patterns, others dismissed it as interference. But a few experts quietly submitted papers suggesting otherwise. They theorized that Earth's magnetosphere had entered a resonant coupling phase, not with the sun, but with a foreign magnetic source. Possibly the same field detected around Three-Eye Atlas's spiraling tail. If true, this meant Earth had momentarily linked, electromagnetically, with an object from interstellar space, and the aurora was the result of that handshake, not light, signal. By dawn, the auroras faded. The sky returned to normal. The sun remained quiet. But one final anomaly remained, a persistent low-frequency hum recorded by ELF stations in Antarctica, a signal buried below the threshold of human hearing. It mirrored the auroral pulses in duration and spacing. But its decay curve was unnatural, too precise, too structured. In other words, someone, or something, had signed off, and the lights in the sky were part of that message. The northern and southern skies had become a canvas, painted not by solar storms but by something far stranger. A pulse, a rhythm, a whisper of contact, and Earth, unknowingly, had just been part of a silent dialogue. With what? No one could say. But the magnetosphere, our planet's shield, now held echoes of a conversation it was never meant to have, and the sky would never quite look the same again. When something breaks the rules of known physics, it forces scientists to re-examine their understanding of reality. On December 16th, as the auroras pulsed without solar wind and Earth's skies responded to something invisible, instruments across the planet locked onto a second phenomenon, a signal. But this one didn't belong anywhere. It didn't come from the sun. It didn't match any Earth-based interference, and it didn't match any known cosmic background source. It arrived on the back of silence, in the vacuum that followed the brief magnetic inversion near the poles. But where silence was expected, a structure emerged. A signal, buried deep within the electromagnetic floor between 0.1 and 3 Hz, far below the range of human hearing and even beneath typical atmospheric noise. It was a frequency Earth never speaks in. At first, it was dismissed. Some claimed it was resonance from the ionospheric rebound. Others suggested it could be linked to the auroral harmonics. But when over 37 independent listening posts across the globe, from Antarctica to Canada, began reporting the same exact waveform, the theory collapsed. The signal wasn't random. It was global, synchronized, and deliberate. And it was perfectly timed to the last visible pulsing of the carbon-drenched auroras. What made the signal impossible was its mathematical signature. Researchers at the National Radio Astronomy Observatory broke it down into its harmonic components. They expected background noise, the chaotic buzz of solar, radiation, lightning, tectonic hum. But instead they found something chilling. The waveform carried a non-random phase progression. It wasn't noise, it was structured, not speech, not language, but pattern. Like the digital heartbeat of an unknown machine. The sequence was made up of repeating harmonic primes, 2, 3, 5, 7, spaced at mathematically perfect intervals. This arrangement doesn't happen in nature, not in Earth's weather, not in cosmic background radiation, not even in the decay of black holes. It was as if someone had inserted a metronome into the vacuum of space. But here's where it turned darker. The signal wasn't broadcasting to Earth, it was echoing from Earth. Subtle Doppler analysis showed a propagation direction starting inside Earth's magnetosphere, then bouncing back from the upper ionosphere, like sonar being used in reverse. Whatever the source was, it was trying to see what Earth sounded like from the inside out. And the timing wasn't a coincidence. The onset of the signal aligned exactly with the final known movement of 3I Atlas's tail structure. Just moments before its jets realigned and a gamma-ray burst was detected nearby, Earth's atmosphere lit up, and this signal was born. A possibility emerged that chilled even seasoned physicists. Was 3I Atlas probing Earth? The idea sounds cinematic, but every measurement added weight to the theory. The magnetosphere had flexed, the ionosphere had vibrated, and now this structured frequency was pinging across the entire upper atmosphere. And then it stopped. After exactly 22 minutes, the pulse faded. No decay, no drift, just a clean, sudden cut-off, much like how a radar is switched off after a scan is complete. In the hours that followed, researchers in Japan and Germany performed a Fourier transform on the signal. Inside the waveform, they discovered a tertiary signature, one that fluctuated not in frequency, but in timing. It resembled pulse-width modulation, a technique used in advanced communication systems, including satellite-to-satellite transmissions. This shouldn't be happening, not without a sender, not without a receiver, and certainly not at frequencies that Earth's natural systems simply don't produce. But that was the final blow to conventional thinking. There was a sender, but it wasn't on Earth, and there may not have been a receiver, because the signal may not have been meant for us at all. It might have been aimed through us, to test resonance, to test feedback, to test whether Earth would respond. And for 22 minutes, under a quiet sky painted in impossible light, it did. The message wasn't words, it was presence. And now that presence had been confirmed, by the sky, by the field, and by the signal that shouldn't exist. After a brief period of visual stillness, when observers assumed 3I Atlas had passed its peak, the object reasserted itself, and it did so with something no one expected to see. Again, a pulse from its tail. But this wasn't like the previous emissions that had baffled spectrometers. This one was sharper, stronger, and far more directed. It felt intentional. The initial return of activity was recorded by the SOAR telescope in Chile, which had been running a continuous observation loop on the tail structure ever since the gamma-ray alignment. For nearly 40 minutes, nothing moved. The particles within the tail remained scattered, almost frozen in space, as if suspended in a perfect stasis. Then, without warning, a shockwave of light and matter began to ripple through the dust field, not from the core, but from the tail itself. This pulse travelled in a fan-shaped formation, expanding outward like an invisible speaker had been activated, pushing against the silence of the cosmos. The particles didn't scatter randomly. They curved, realigned, and then spiraled inward toward the comet's axis, suggesting an electromagnetic control far beyond what a natural outburst would show. What made the return of the tail pulse so stunning was its synchronicity with Earth-based magnetic fluctuations. Just as the tail activated, magnetometers near the equator, typically unaffected by polar disturbances, recorded a brief surge in high-frequency harmonics. This wasn't a correlation anyone expected, but it implied something profound. The tail might be tuning itself to the planet. Unlike typical cometary jets, which burst in chaotic plumes based on solar heating or rotational stress, this structure exhibited behavior more akin to a phased array, an engineered system capable of focusing energy in a specific direction by altering timing patterns across its surface. If that sounds familiar, it's because it's the same principle used in modern radar systems. So now the question wasn't just, why did the tail pulse again? It was, what was it aiming at? Researchers across observatories, in Europe, Asia, and the American Southwest, compared readings and isolated the directional vector of the pulse. What they found startled everyone. The pulse had been angled back toward the gamma-ray burst's original point of origin, nearly 1.6 degrees off from Earth's orbit plane. That's too precise to be random. It was as if 3i Atlas had received something, a burst, a scan, a trigger, and was now responding. Theoretical physicists at the University of Chicago modelled the behaviour and came to a controversial hypothesis. The tail wasn't just reactive, it could be reprogrammable, a dynamic array capable of shifting geometry in response to remote stimuli. That would mean the object was not only collecting data, but interpreting it. And once again, the composition of the particles shifted. Earlier observations of the tail showed a dominance of ionized carbon and water vapor. But after this pulse, new signatures began to emerge. Traces of barium, yttrium, and even a compound loosely resembling synthetic silicate clusters, the kind used in experimental photonic computing. These elements have no reason to form naturally in such a structure, especially not in the outer solar system. This change in signature hinted at active fabrication within the tail, as if the burst wasn't just a release of energy, but a transformation protocol. On Earth, scientists raced to update their models, because if the tail was evolving, and if it was responding to Earth-adjacent events, like the gamma-ray burst or the ionospheric resonance, then 3i Atlas wasn't a passive traveller, it was a system, one that receives, reacts, and now emits. The tail wasn't just a residue, it was a device, and its reactivation didn't just speak of motion, it spoke of intelligence. Something had awakened inside it, and Earth once again was in its path. When radio telescopes began scanning 3i Atlas following the tail's sudden reactivation, something unexpected began to emerge from the static, a pattern. It wasn't a clear signal, no voice, no Morse-like rhythm, but rather a recurring pulse of silence, a rhythmic absence of frequency. Like a heartbeat made of gaps, and it repeated, exactly. At first, it was dismissed as internal instrument interference. After all, the instruments had just undergone recalibration after being overwhelmed by the gamma-ray burst near the object. But as more facilities around the globe began to detect the same void-shaped pulse, even from arrays tuned to different bands, the phenomenon could no longer be ignored. They called it the memory echo. Unlike previous emissions from 3i Atlas, which had been largely visual or kinetic in nature, tail shifts, spectral changes, core flickers, this was purely temporal. It was as if time itself was being manipulated in these repeating intervals. The pulse wasn't about light or radiation or chemical data. It was a pause, a deliberate skip embedded in the radio silence, and it was perfectly spaced. One pulse every 1.1 seconds, then a gap, then another 5 identical pulses, then silence. Then the whole sequence would start again. 5 repeating groups, always 5. This repetition didn't match any known cosmic behavior. It wasn't stellar in nature, and it wasn't caused by orbital dynamics. It was, for lack of a better term, structured memory, like an artifact repeating its last stored command. A theory emerged among SETI engineers. What if 3i Atlas wasn't emitting a new signal, but replaying one? The term echo took on a new meaning. Not an acoustic return, but a stored fragment of something it had once encountered, maybe light years away, something ancient, something buried. Several observatories began overlaying the rhythm onto older gamma-ray burst catalogues. They wanted to know, had this object heard something before? And more importantly, was it repeating it now deliberately because of Earth's proximity? That's when the eerie alignment was discovered. The time signature of the memory echo matched, down to the decimal, a GRB event logged 12 years ago, just outside of the Virgo cluster. That burst, GRB 30624R, had been dismissed at the time as background noise, its energy modest, its duration short. But what if it wasn't background? What if it was a message, and 3i Atlas was carrying it? The memory echo's timing pattern, when mapped visually, created an angular shape, 5 repeating arms in a spiral curve, not unlike the golden ratio or the Fibonacci arc seen in biological systems and even in galaxy structure. This was no longer just science. It was moving into the realm of design. Material scientists working in parallel discovered something else. The tail, which had previously released synthetic silicates, had begun to form crystalline alignment chains, almost like data grooves. These were microscopic structures, impossible to see except under polarized infrared imaging. But they repeated the pulse rhythm. It was physically embedding the echo into its own material. So now the comet, or whatever 3i Atlas truly was, wasn't just storing a pattern, it was becoming the pattern. And that's when the final piece dropped. During a sweep by the Canadian Hydrogen Intensity Mapping Experiment CHIME, the memory echo appeared to modulate slightly as Earth rotated beneath it, tightening when the Pacific was facing it, and softening when the Atlantic did. That fluctuation suggested it was interacting with Earth's rotation, or geography, like a code waiting for alignment. The implications were dizzying. If the memory echo wasn't just a recording but a trigger, then 3i Atlas might not be delivering a message to Earth. It could be waiting for a reply. And the only question left was, who or what is it waiting for? As researchers tracked the gamma-ray echoes and tail structures of 3i Atlas, the object was already entering the next stage of its transformation. This time, it wasn't a burst. It wasn't a flicker. It was a formation, cold, precise, and entirely out of place. Infrared arrays aboard the James Webb Space Telescope captured it first. Then, minutes later, confirmation came from China's FAST telescope and an auxiliary antenna system stationed in Norway. They all detected the same geometric anomaly, a hexagonal grid emerging along the dark side of 3i Atlas's midsection. This wasn't a visual illusion, nor a random pattern in the comet's debris field. It was consistent, 60 repeating nodes connected by angular filaments, aligned in perfect unison, spaced not by gravitational drift, but by something far more rigid. It looked like scaffolding, or a circuit board, suspended in the vacuum of space, and it was aligned directly toward Earth. At first, the team at NASA's Deep Space Network theorized it might be a result of cryovolcanic crystallization. Some comets do exhibit patterned ridges under extreme cold, as frozen gases shape the surface from the inside out. But those are always chaotic, never symmetrical, never artificial. This grid violated every natural law of chaotic surface evolution. The filaments didn't fracture, they didn't drift. They remained perfectly intact, and they glowed. Yes, they glowed. Not brightly, not in any human visible way, but in a narrowband ultraviolet emission not usually associated with comets. In fact, it was the same band used in Earth-based LiDAR systems for terrain scanning. Why would a deep space object produce UV filaments that look eerily like Earth technology? That question gained weight when the European Southern Observatory, uploaded a high-exposure composite from 12 separate telescopes. The image revealed something far worse than just filaments. Inside each hexagonal node of the grid, embedded between the glowing arms, were spiral coils, metallic-looking loops etched into the material. They weren't reflective. They absorbed light completely. And they were identical in shape and spacing to each other, like manufactured parts. Material scientists went into overdrive. Some compared the structure to Tesla coils, while others noted the spacing resembled ancient antenna arrays, including designs proposed for deep space communication during the Cold War that were ultimately scrapped due to instability. Yet here, on this interstellar object, those same structural motifs were perfectly executed. But one detail pushed the event into full-scale alert mode. When aligned against the memory echo discovered earlier, the spacing of the coils matched the timing intervals of the signal. Each coil was effectively a timestamp, like a physical clock laid out in 6 dimensions. The grid wasn't random, it was a storage system, and it had just turned itself on. Spectral emissions around the grid increased dramatically, not in temperature, but in signal density. It was now absorbing surrounding radiation, from solar wind, cosmic rays, even Earth's own background transmissions, and reflecting it back compressed into a thin frequency band that hadn't been seen in space before. The waveform it produced wasn't chaotic, it was predictive. It bent toward Earth's atmospheric resonance bands, as if it was trying to interface. NASA's Jet Propulsion Lab, reviewing historical mission data, found nothing comparable. Not even in near-Earth asteroids with artificial satellites, not in Mars orbit, not even in the Voyager Golden Record emissions. This wasn't just advanced, this was impossible, and yet it existed. That night, several agencies privately circulated a new name for the anomaly, no longer just a grid. They called it the interface layer, because whether it was built to receive, to transmit, or to transform, no one knew. But its orientation toward Earth hadn't changed, and the grid, it was still growing. As the strange hexagonal grid on 3i Atlas continued to grow and pulse with ultraviolet energy, something else shifted, not in the comet itself, but in Earth's own data field. On the morning of December 15th, at precisely 04:17 UTC, deep space listening arrays across 3 continents captured a single compressed pulse from the direction of the object. It wasn't noise, it wasn't a flare, it was data. At first, the waveform looked like gibberish, a tightly packed set of modulated frequencies that didn't correspond to any known natural signature. But when the signal was time-dilated, a structure began to emerge. It wasn't random. It had intervals, recursions, and embedded harmonics, traits that hinted at compression algorithms, like those found in binary data packets, and in its center was a symmetrical structure that resembled a spatial coordinate system, a grid, not just in space, but in space-time. Teams at the European Space Agency and NASA's Ames Research Center began running simulations using the waveform as a seed. The coordinates weren't galactic, they weren't anchored to constellations or fixed star maps. Instead, they were relative to gravitational nodes within our own solar system: Jupiter, Saturn, Earth, even the Moon. It wasn't a message meant for the galaxy, it was a message built for us. And when overlaid with recent orbital shifts, tail vector alignments, and minor gravitational anomalies observed since 3i Atlas entered the inner system, the signal produced a predictive map. One that outlined the future trajectory of not just the comet itself, but of 7 objects trailing behind it. 7 smaller fragments, previously dismissed as debris, now reclassified as companions, each one with its own projected orbital entry point, and all 7 were heading toward Earth's orbital path. The signal had encoded a warning, but it also embedded instructions. A small team of cryptographers at MIT began analyzing the deeper modulations within the pulse. At layer 3 of the waveform, they found something bizarre: spatial inversion patterns. These weren't audible frequencies, but encoded vector reversals, effectively a physics template. When simulated in fluid dynamics models, the pulse generated a field effect that nullified incoming radiation. It was a shield, a model, a technology blueprint, embedded in a gamma-ray burst, and the implications were staggering. This meant the object not only transmitted awareness of its companions, but also delivered a solution, or depending on interpretation, a test. Because the signal wasn't sent until after the gamma-ray event was detected, after the memory echo, after the grid was fully formed, as if it waited for confirmation and then released the next phase. The signal didn't end after the pulse, it kept looping. Every 91 minutes the entire burst re-emitted from 3i Atlas, but with subtle variations. Each cycle had a new layer. Each layer revealed more about the internal mechanics of the object. Thermal resonance models, updated in real time, showing how the internal core now matched not ice or rock, but something far denser, with self-regulating magnetics. Whatever was inside 3i Atlas wasn't passive. It was adjusting itself with each signal cycle, feeding off its own transmission, adapting. And one last twist shook the global community of astrophysicists. When Earth's magnetosphere briefly fluctuated at the poles, barely a ripple in the overall field, instruments detected a return ping, a soft, precise reflection from the core of 3i Atlas, in sync with the magnetosphere. Not a coincidence, not a fluke. The object had responded, it had mapped us, understood us, and sent a message using a format we weren't supposed to understand yet. The solar system hadn't just received a burst, it had been invited to decode a deeper layer of reality. And the map? It was just the first page. For months, we treated 3i Atlas like an anomaly. A comet that burned too long, glowed too cold, and moved too deliberately. But now, with the arrival of this gamma-ray event with its embedded signature and impossible data, something else is becoming clear. This object didn't just enter our solar system. It learned from it. It mapped our physics. It responded to our magnetosphere. And then, it spoke back. And what it said wasn't a threat. It wasn't a countdown. It was a doorway. Because the truth is, we were never just observing it. It was observing us. And now, with every 91-minute cycle, with every faint returning ping, it's showing us how much we never understood about our own sky. So the question isn't what 3i Atlas is. The question is, what did it just unlock? And what happens the next time it speaks, and we finally understand the full message? If you're still listening, watch the sky, because this story isn't over. It's just beginning.